Okay, so today we're looking at question 1F from the 2018 Oxford MET exam, and it goes like this. So we're told that a particle moves in the xy plane and it starts off at the origin, so 0, 0. And then at each turn, the particle can move in two different ways. And these are as follows. So we can either move to the right by 2 and then up by 1. So it's a translation by vector 2, 1. Or secondly, we can move to the right by 1 and up 2. So that's another translation, this time by 1, 2. So those are the only two ways that our particle can move in the plane. And then the question is, what is the closest that this particle can possibly get to the point 25, 75? And we're given some possible answers. Okay, so we're told that this particle can move in exactly two different ways. So it can either move to the right by 2 first and then up 1, or it can move to the right by 1 and then up 2. So let's have a look what this looks like graphically on the plane. So this is our xy plane, and we're told a particle starts at the origin. So if it can only move in these two ways, then it's always going to be up in this quadrant. We know that for starters. And we can also say more, we can bound this in a region. So this movement here, we can think of moving on the line x over 2. So like this. So if we just use this operation, we'd only lie on points on this line. And this line has gradient x over 2. And equivalently, this movement is going to be the line 2x. So if you only to use this movement, we'd lie always on points on this line. So if we use a combination of these two, it means we're bounded in this area. So we're always going to be in this region between these two lines. So remember that we're trying to get as close as possible to the point 25, 75. And this is going to lie just above this line here. So this is going to be 25, and this height here is 75. We know that because this corresponds to a line of gradient 3x. If we sketched on the line 3x, then it would lie on this line. So we know that this point is strictly above this region. So in some sense, we don't really want to use this operation because this isn't going to get us any closer to this point. So ideally, we only want to be using this operation. So let's consider points that only lie on this line. This is how we're going to get as close as possible to this one. So now the way I like to think about it, there's a few different ways you can approach this. The way I would approach this is find the point that is closest to the target point, 25, 75. And one way of doing this is by finding the orthogonal line, so the line that is perpendicular to this line, and that it passes through the target point. So if we can find the equation of this line, then we can find where this line intersects the 2x line, and that would give us the point. So first we need to find the equation of the orthogonal line. I'm going to call this line y perpendicular. So you might remember that if we have a line, I'll call this a general line, y equals mx plus c, then the equation of the perpendicular line is going to be, it's going to have gradient minus 1 over mx. And this little constant here, this is called the negative reciprocal of m. And then we could have any other constant, it doesn't really matter. But this line is going to be perpendicular. So this is just a little recap. So if we've got a line y equals 2x, then our perpendicular line has to have gradient minus a half, just using this formula, right? We've flipped it and then put a minus sign. So that's going to be the gradient of y perpendicular. And then we need to find the constant, let's just call it c dashed. And this constant, so that it satisfies, it goes through 25, 75. And to find this constant, we just substitute in this coordinate and rearrange. So we put in 75 on the left-hand side, that's the y coordinate, and then minus a half, the x coordinate, which is 25. And we have plus c dashed. So if we rearrange and solve this equation, we get that c dashed, the constant, is 175 divided by 2. So that tells us that the equation of our line is actually, if I just go up here and rub this out, the equation of the line is this one right here. So minus a half x plus 175 over 2. So this is the equation of this perpendicular line that goes through this coordinate that we're trying to reach. And now, as I was saying earlier, we want to find the point that's closest to this point. and it's going to lie on this line, but it's also going to lie on the line y equals 2x. So to find this coordinate, we just need to solve the equation, find the point where it intersects. And to do that, this is fairly standard. We just set these two equations equal to each other. So minus a half plus 175 over 2 equals 2x. Right, so the solution of this equation gives us exactly this intersection point, this cross here. And then this is fairly simple as well. We just bring the x's onto one side, gives us 5x over 2 equals 175 over 2. And then the 2's cancel, divide by 5, we get x equals 35. And that's especially nice because this is an integer, which means that we can actually reach this point using our operations. So we know it lies on the line 2x, which means the height is going to be 2 times that, which is 70. So this coordinate right here, let's just recap. We found that it lies on the line 2x. It also lies on the perpendicular line, which means this point is going to be the closest that we could possibly reach to the point 25, 75. So any other point in this region is going to be further away, and any other point on this line is also going to be further away. You can just imagine drawing a triangle, and you know that the length of the hypotenuse is always longer than the other two sides. So that's kind of how you prove that this coordinate is the closest you could ever reach. So I think the rest of the question was trying to find out how close that coordinate was, and that's just using the distance formula. So if you remember, you take the square of the coordinates, so we have 35 and 25. So 35 minus 25, the distance between these two, square it. This is just Pythagoras really. And then 75 minus 70 squared. Take the square root of that, and then we can simplify. So this is 10 squared, this is 5 squared, which would come out as the square root of 125, and this is 5 root 5. So this is the distance exactly here between these 2 points, and that's the solution.